Okay, it's Mr. Dittmer from American Indian Public High School, covering Algebra 2, Chapter 9, Section 6, which is everything to do with solving rational equations. That's Chapter 9, Lesson 6. And so we're going to do a few examples. But basically, just to be clear, 9.4 and 9.5 were about simplifying rational expressions. We wanted to add, subtract, multiply, divide rational expressions. And rational expressions just were expressions with x in the denominator. And, you know, it was just like at the very first chapter of the year, we started solving, we started out simplifying like we're doing here, simplifying expressions. And, for example, 5x plus 3x. So we had to focus on how to simplify an expression like that. But then once we learned to do that, then we started solving equations with that in it. So solve the equation. So once we know how to simplify the expressions, then we can solve the equations. So now that we have x in the denominator, it's a little more, maybe a few more steps, but it's basically the same idea. So here's our first example. Now the step that the suggestion here is to take all the time when solving these things, multiply both sides by the LCD. Multiply both sides by the lowest common denominator, which is the same as the least common multiple of the two denominators. So each of the denominators is a number. What's the least common multiple? And then that's your lowest common denominator. So here, I've got 2 and I've got x. So my lowest common denominator is 2x. So I'm going to multiply everything by 2x. And when I multiply a fraction by something like 2x, it's really 2x over 1 that I'm multiplying it by, right? So multiplying everything by 2x, and I'm going to get 8x over x, 1 times x, plus 10x over 2 equals negative 22x over x. And well, you're like, well, I still have different denominators. Yeah, well, but this cancels. This is going to reduce. And this is going to, these cancel. And so I've got just 8 plus 5x equals negative 22. I'm going to add or subtract 8 from both sides. And so I'll have 5x equals negative 30. And oops, that's not an answer. Beg your pardon. Divide by 5 on both sides, x equals negative 6. Okay, let's try another one. So because sometimes these get weird. Let me show you. So here's an example of one that's going to get weird. 5x over x minus 2 plus 7. 5x over x minus 2 equals 7 plus 10 over x minus 2. So again, what's our lowest common denominator? And realize the denominator here is 1. If it's not there, then we know it's 7 over 1. So the lowest common denominator is, if you guessed x minus 2, you're correct. So multiply everything by that. So we'll have 5x times x minus 2 over x minus 2 equals 7x minus 2 over 1 plus 10x minus 2 over x minus 2. Now maybe you won't want to write all that when you're doing it, because maybe you'll automatically in your head say, oh, these are canceling. When I multiply by the denominator, the whole point is to cancel this. So really what you'll have is 5x equals, now this one doesn't cancel, 7x minus 14 plus 10. And from there, I can subtract the 7x from both sides. minus 7x and minus 7x. And so then I've got negative 2x equals, and negative 14 plus 10 is negative 4. Negative 2x equals negative 4, so x equals 2. Okay, makes sense? Enjoy it making sense for a moment because it's not actually our answer. See, we have to check it. And what happens when we check it, take this answer and plug it back in, is what does it do? I mean, you could say, oh, it makes the numerator here 10, but it makes the denominator 0 if I plug in 2. So it's like some undefined number equals 7 plus another undefined number. So that's called an extraneous solution. So I'll write that down so you know, again, how it's spelled. Extraneous solution. In other words, a false solution. And yeah, there you have it. All right, our next example. Here we've got x plus 1 as the denominator on one side, and x plus 1. So x squared minus 1 is the denominator on the other. And you might want to multiply this times this, but it's always important to factor first if you can when coming up with the denominator. Just like, you know, if you were trying to find the lowest common denominator between 6 and 12, you wouldn't want to multiply the two. You know, you want to factor, realize this is actually 2 times 6, and so really it's just 12 is the lowest common denominator. So similarly here, I want to factor, and I want to realize that this is actually x squared minus 1 is a difference of squares, so it's actually x plus 1 times x minus 1. So now I know that this goes into this, and so this is actually my lowest common denominator, the bigger number. So all I have to do is then, not apparently, but for sure, I've got to multiply everything by this, right? So if I multiply this over here by that, I'm going to try to save space here. 4x plus 1. The x plus 1s I'm multiplying by will cancel out. So I'm multiplying, x plus 1 will join the numerator, cancel with the denominator. The x minus 1 will stay, it's part of it. And since I canceled the denominator, that's going to be what I have over here. Now, when I multiply this one, multiply it over here, the whole thing will cancel out, and I'll just get 12. And then when I multiply it by 3, none of it will cancel. I'll get 3 times x plus 1, x minus 1. Or just x squared minus 1, say. I'll show you in a future slide with everything blown up so you see every step. But for now, now we can expand this, so by multiplying. So plus 1x on the inside and minus 4x on the outside gives me minus 3x minus 1 equals 12 plus 3x squared minus 3. Subtract 3x squared from both sides, and we have just x squared. No x over on that other side, so we'll just keep the minus 3x. And the minus 1 here will be joined by minus 12 plus 3. So we've got really 9 on this side, so minus the 9 on both sides, we have minus 10 equals 0. If x squared minus 3x minus 10 equals 0, I'm going to erase on the top to make some space. What are we going to do next? If you said factor, that's correct. So x squared minus 3x minus 10, that's x plus 2 times x minus 5, right? Equals 0. So x equals -2 or 5. Now, if you want to see all the steps, here we go. Okay, so first step is factor this part. Factor this to here. The next step is figuring out, since that's the LCD, multiply all three terms, 1, 2, and 3, by that LCD. So there you have it. The first term here, the second term here, third term I had to run out of space. It's right here. 3 times x plus 1, x minus 1 here. And then the next step is cancel. So we're going to cancel here and here. And nothing to cancel over here because it's over 1. So that's how we get this. So this, after it cancels, becomes this. And then we go FOIL on the left, and we get that stuff over there. FOIL on this side, and the middle terms cancel out, and we just get this. And keep going, we get that, and then we subtract the 3x squared, and combine. Well, actually, before we do that, we should simplify the 3 and the 12 to get that 9. Then we could subtract the 3x squared. We get x squared plus minus 3x plus 1 equals 9. And then we look back and we see that we messed up. It was never plus 1, it was minus 1. From right there. And that means now we can subtract 9 from both sides, and that'll give us x squared minus 3x minus 10 equals 0. And then we factor this, and that gives us the answer 5 and -2. Now, we should plug those back into our original equation to double check that it's right. But I'm peeking at the book, and it is, and so that's nice. Okay, so one more thing to try, or maybe two, but at least one. There's another method to doing this problem. Besides just multiplying by the LCD, the other method is to get it to be a proportion by combining. These are like terms, right? Or they have like denominators. So if I just subtract 4 over x from both sides, I'll cancel it out here, and I'll have 5 over 2 equals -11 over x minus 4 over x. And -11 minus 4 is -15. When I have it without, I've gotten rid of my plus signs and I just have a proportion, one fraction equals another fraction, then I can cross multiply. And I can say -30 equals 5x. -30 is 2 times -15. Divide by 5 on both sides, and I got x equals -6. So that's one way to do some of these problems. Last slide, I just want to look at a word problem quickly, but yeah, maybe it'll have to be another video. It was one of the, this is the problem that I wanted to make you have a look at. It's but it's on page, I'm out of my 15 minutes, or just about up. It's on page 570. So if you want to get ahead, see if you can't figure out what they're talking about on page 570, example 5. That's all for section 9.6. See you tomorrow.